Good morning all. Welcome to another lecture. In the last lectures, we discussed the concept of sets and its operations along with its various properties. Today we will focus on the cardinality of a set. We are starting here with the cardinal numbers of a set, which is the numbers of elements in a given set, along with some practical examples. See, what do you mean by the cardinality? The concept of cardinality or the cardinal numbers of a set is the numbers of elements in a given finite set. It shows that the size of a particular set. The numbers of elements in a finite set A is symbolically denoted by n of A, that means number of element in the given set A. For example, if we have given set A is equal to 1, 2, 3, 4, 5, then the number of element in the given set A, which is equal to 5, because there are 5 elements in the given set. So it is obtained by counting the actual elements within the given set. So here we can say that 1, 2, 3, 4, 5. So we have the only 5 elements are there in the given set. However, we can find the numbers of elements in a finite set by using different formulas or by using Venn diagram as well. So we are going to discuss that particular formulas here. See, let us consider we have two sets, that is set A and set B, and these two sets are the finite sets. Then we are also assuming that these two sets are disjoint sets, that is A intersection B is equal to 5, or we can say that these two sets are mutually exclusive sets. Then the formula for calculating the numbers of element in a given set, that is number of elements in the A union B, which is equal to number of elements in the set A plus number of elements in the set B. So in general, we can say that if A and B are finite sets and if they have overlapping elements are there, that means these two sets are not a disjoint sets. There are certain common elements are there. Then the formula for calculating the numbers of elements in a given set is here, that is number of elements in the A union B is equal to number of elements in the set A plus number of elements in the set B minus number of elements in the A intersection B. That means the cardinality of the union of set A and B is equal to the sum of the cardinality of each set, that is number of elements in the set A plus number of elements in the set B minus the cardinality of their intersection, that is number of elements in the A intersection B. So by doing so, we can avoid the double counting when we computing the size of union. So now let us consider if we have more than two sets. For example, we have three sets are there, that is set A, B and C. Then the number of elements in the union of three sets can be calculated by using the formula, that is number of elements in the A union B union C, which is equal to number of elements in the set A plus number of elements in the set B plus number of elements in the set C minus number of elements in the A intersection B minus number of elements in the A intersection C minus number of elements in the B intersection C plus number of elements in the A intersection B intersection C. See, using this particular formula, we apply inclusion and exclusion principle to the three sets. It is look like it is too lengthy, but it is very easy to follow and remember. And this formula is account the size of each individual sets, removing the size of their pairs, that is pairwise intersection. So in order to avoid the double counting problem, we are taking the pairs of intersection and then we are adding here, see, the size of their triple intersection to correct any type of exclusion. So triple intersection here, it is the number of elements in the A intersection B intersection C. So by using this particular formula, you can find the number of elements in the A union B union C. Now sometime we want to find out the numbers of elements of complement of a set A. That is number of elements in the A complement, which is equal to the number of elements in the universal set minus number of elements in the given set A. So here we can say that number of elements in the A complement, which is equal to number of elements in the universal set minus number of elements in the given set A. So this particular formula actually shows that numbers of elements in the complement of set A is the total number of elements in the universal set minus the numbers of elements in the given set A. So if we have two sets, let us consider set A and set B. Then the numbers of elements in the certain intersection involving set complements can also be calculated. That means if we have two sets, that is set A and set B, then the numbers of elements that are only in set A and not in set B, we can find it by using the formula, that is number of elements in the set A only, which is equal to number of elements in the set A intersection B complement, which is calculated by using the formula, that is number of elements in the set A minus number of elements in the A intersection B. Similarly, you can also find the numbers of elements that are only in B but not in A. So that can be found by using the formula, that is number of elements in the set B only, that is numbers of elements in the B intersection A complement, which is equal to number of elements in the set B minus number of elements in A intersection B. See, in both the equation, our purpose is to count the numbers of elements that belongs to a particular set, that is either in the set A or set B, but exclude the elements that are not in the both sets, that is set A and set B, so that we can avoid the double counting problems. So these formulas are the fundamentals in the set theory and provide a basis for counting and understanding the size of a particular set and their operation. So based upon all these formulas, we can solve number of practical problems. So consider some example. We have given that if set A and B are such a that A intersection B has 40 elements, A has 25 elements and B has 30 elements. And how many elements does A union B have? See, given the information, see A number of elements in the A intersection B is equal to 40. And the numbers of element in the set A, which is equal to 25. And numbers of element in the set B is equal to 30. And we want to find out numbers of elements in the A union B. So now applying the principle of set operation and their inclusion and exclusion principle, we can say that the number of elements in A union B is equal to number of elements in the set A plus number of elements in the set B minus number of elements in the A intersection B. So all the information are given here. So we are just going to substitute here, then it will become number of elements A, which is equal to 25 plus number of elements in B, which is equal to 30 minus number of elements in A intersection B, which is equal to 40. So it will become 55 minus 40, which is equal to 15. So the number of elements in the union of set A and B is equal to 15. So in this way we can find the numbers of elements in A union B. Now consider the another example. If A and B are two sets such that A union B has 50 elements, A has 28 elements and B has 32 elements, how many elements does A intersection B have? See, what are the information given here? A number of elements in A union B, which is equal to 50. So I have written here the numbers of elements in this set A which is equal to 28 and numbers of element in the B which is equal to 32, and we want to find out numbers of elements in A intersection B. So by applying the formula, that is, we know the numbers of A union B is equal to numbers of the elements in the set A plus numbers of elements in the set B minus numbers of elements in the set A intersection B. So what are the information here? We are just going to substitute here numbers of A union B which is given, which is equal to 50, numbers of element in A which is equal to 28, numbers of elements in the B which is equal to 32 minus this numbers of elements in A intersection B which we want to find out. So which is equal to, by solving this particular numbers, then it will become 28 plus 32 minus 50 which is equal to 60 minus 50 which is 10. So numbers of element in A intersection B is equal to 10. So the number of element in the intersection of two sets, that is A intersection B, is equal to 10 here. Now we have another example. See, in a schools there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics, 4 teach both physics and mathematics, and how many teach physics and how many teach physics only? See, here we can denote the subject mathematics and physics. The numbers of teachers who teach the mathematics I am denoting in terms of M, and the numbers of teachers who teach the physics, see, I am denoting in terms of P here. And in the given problem, see, the word used here, it is mathematics or physics, which is generally give us a clue for the union. And the word here, it is used physics and mathematics, which is give us a clue for the intersection. So by using this given problem, we can have the informations like, numbers of, teachers who teach the mathematics and or physics which is equal to 20. So here who teach the mathematics or physics, we can say that it is mathematics union physics which is equal to 20. And of these 12 teachers mathematics, so numbers of mathematics teachers, here it is 12. Then here 4 teach both physics and mathematics. So here it will become intersection of the teachers who teach the physics and mathematics. So here numbers of elements in M intersection P which is equal to 4. We want to find out numbers of elements in the physics only. That means numbers of teachers who teach the physics and the numbers of teachers who teach the physics only. So we know by using the given information, the numbers of elements in M union P which is equal to numbers of elements in M plus numbers of elements in P minus numbers of elements in M intersection P. We substitute this given information here so that it will get, see, M union P which is equal to 20, which is equal to number of elements in M which is equal to 12 plus number of elements in P which is not given, then the intersection is given which is equal to 4. So if you solve it for isolating numbers of elements for P, then it will become 20, 12 minus 4 which is equal to 8. So it is numbers of elements in P which is equal to 20 minus 8 which is equal to 12. So hence we can say that the numbers of teachers who teach the physics which is equal to 12, that is 12 teachers are teaching the physics. So first question is solved here. And the second question here, how many teachers teach the physics only? So here numbers of elements in P only which is equal to numbers of elements in P intersection M complement which is equal to numbers of elements in P minus numbers of elements in M intersection P. So here numbers of elements P which we are already calculated here, it is 12 minus the intersection which is equal to 4. So 12 minus 4 which is equal to 8. Therefore we can say that 8 teachers who teach physics only, and the number of teachers who teach physics which is 12, at the same time number of teachers who teach physics only which is 8. Now we are going to consider another example. In a town of 5,000 people, 2,800 person read Hindustan newspaper, 2,300 read Times of India, and 400 read both. How many do not read any newspaper? So first we are going to write down what are the information given in this particular question. That is, the total population is given. So before that, here I am denoting H for the Hindustan and T for the Times of India newspapers. So here the total population, that is numbers of element in the universal set, that is equal to total population in the given town, that is 5,000. And then the numbers of people who are reading the Hindustan, which is equal to 2,800. Then the numbers of people who reading the Times of India, which is equal to 2,300. And the numbers of people who read both Hindustan and the Times of India, which is generally known as it is intersection, H intersection T, which is equal to 400. So in order to find out the numbers of people who do not read any newspaper, first we want to find out how many people who read any of the newspapers. Then we can go for finding numbers of people who do not read any newspaper. So in order to find out the numbers of people who read any of the newspaper, we just want to find out the union of H and T. So it will become, see, union of H and T, which is equal to numbers of elements in H plus numbers of element in T minus numbers of element in H intersection T. So it will become 2,800 plus 2,300 minus 400, which is equal to 4,700. Therefore, this 4,700 showing that numbers of people who are reading the newspaper, any of the newspaper. And here we want to find out how many people who do not read any of the newspaper. So in order to find out the numbers of people reading none of them is equal to the total population of the people minus numbers of the population who are reading any of the newspaper. So here it will become, it is numbers of elements in H union T complement we want to find out. So which is equal to numbers of element in the universal set minus numbers of elements in H union T. So here our population, that is our universal set, is equal to 5,000 minus those people who are reading the newspaper, any of the newspaper, which is equal to 4,700. So which is equal to 300. And this 300 is actually showing that the numbers of people who do not read any newspaper in the given town, which is equal to 300. See, here we have given another question. In a class of 30 students, 15 students have taken English. 10 students have taken English but not French, which means that these students are taken English only. We have the question that find the numbers of students who have taken French and French but not English. That means French only. So here we are denoting here the subject English is equal to E and the subject French is equal to F. And from the given question, what are the information given here? The numbers of element in E union F, English union French, which is equal to 30, and 15 students have taken English. So it is number of elements in E is equal to 15. And the other information are 10 students have taken English but not French. So it is numbers of element in E intersection F complement, which is equal to 10. So by using this particular information, we have the equation. We know that it is numbers of element in E union F, which is equal to numbers of element in E plus numbers of element in F minus numbers of elements in E intersection F. But here two things are not given, that is numbers of elements in F and the numbers of elements in E intersection F. These two are not given, but the given information, that is numbers of elements in E intersection F complement, is given. That means the numbers of element E only is given, which is equal to numbers of element E minus numbers of element in E intersection F. So by using this particular equation, we can substitute here. See, numbers of element E is equal to 15 and numbers of E intersection F complement is equal to 10. By using these two information, we can substitute here, then it will become, see, numbers of elements in E intersection F which is equal to 10, which is equal to numbers of element in E which is equal to 15 minus numbers of elements in E intersection F. Therefore, we can solve this particular formula for numbers of elements in E intersection F which is equal to 15 minus 10 which is equal to 5. So, we got the numbers of elements in E intersection F which is equal to 5. Now, by using this given information, we can solve this particular equation number 1, that is numbers of elements in E intersection F which is equal to numbers of elements in E plus numbers of elements in F minus numbers of elements in E intersection F. So here, what are the information given? This is given. Numbers of elements in F we want to find out here. So by substituting all other information, then it is equal to E union F which is equal to 30. Then numbers of elements in E which is equal to 15. We want to find out numbers of elements in F minus the intersection which we are already estimated here, it is equal to 5. So if you solve it for numbers of elements for F, then which is equal to 20. So the numbers of students who have taken French is equal to, it is 20. Now we want to address the second question, that is the numbers of students who have taken French but not English, which means that how many students are taken French only. So for that we are using the formula, that is numbers of students who taken the French only which is equal to numbers of elements in F minus numbers of elements in F intersection E which is equal to, numbers of elements in F which is equal to 20 minus the intersection, that is 5, so it is 15. So we can say that the number of students who have taken French but not English, that means French only, which is equal to 15. Now we have another example. In a survey of 200 students of a school, it was found that 120 students studied the mathematics, 90 studied the physics, 70 studied the chemistry, 40 studied the mathematics and physics, 30 studied physics and chemistry, 50 studied chemistry and mathematics, and 20 studied none of these subjects. We want to find out the number of students who studied all three subjects. See, from the given information, I am just denoting here. See, the universal set is equal to 200 students because the survey is conducted among the 200 students of the school. So the universal set is equal to 200. And it was found that 120 students studied the mathematics. So I am denoting M for the mathematics, P for the physics, and C for the chemistry. So here, by using this information, see here, numbers of mathematics which is equal to 120, numbers of elements in P which is equal to 90, numbers of elements in the chemistry which is equal to 70, and numbers of elements in the M intersection P which is 40, numbers of elements in P intersection C which is equal to 30, numbers of elements in C intersection M which is equal to 50, and see last information which is given here, the 20 studied none of these subjects. That means numbers of students, that is who do not studied M, that means mathematics, physics and chemistry is equal to 20. And we want to find out numbers of students who studied the physics, chemistry and mathematics. So first we are going to find what is the union of these three sets, that is numbers of students who studied the mathematics, physics and chemistry which is equal to numbers of students in the universal set, that is equal to 200 minus the complement, because here the information given 20 studied none of these, so it is complement. So if you subtract the M union P union C complement from the given universal set, then you will get the union of mathematics, physics and chemistry. So it is equal to 200 minus 20 which is equal to 180. So once the union is ready, then we can go for finding out the intersection of these three sets. So by using our equation, see this is our equation for calculating the union of the three sets. So by using this formula, see what are the information given here. We are just going to substitute all these things here in the given formula. Then it will become, see, numbers of elements in M union P union C, which we are already estimated here, it is 180, which is equal to numbers of elements in M, which is equal to 120 plus 90 plus 70 minus 40 minus 30 minus 50 plus. See, we want to find out number of students who studied all these three subjects, that is physics, chemistry and mathematics. So we want to find out numbers of elements in P intersection C intersection M. So if you solve this particular equation for numbers of elements in P intersection C intersection M, then it is equal to 180, which is equal to 280 minus 120. So it is 180 minus 160, which will give the numbers of elements in P intersection C intersection M. And what is this showing? That it is the 180 minus 160, which is 20 students. These 20 students are studied all these three subjects, that is numbers of elements in physics, chemistry and mathematics. That is all these three subjects are studied by 20 students. Now we are going to consider the another example. See, in a class of 50 students appearing for the examination, 20 failed in accounts, 21 failed in mathematics and 27 failed in costing. 10 failed both accounts and costing, 13 failed both mathematics and costing, 7 failed both accounts and mathematics. If 4 failed all the three subjects, then we want to find out the numbers of students who failed in accounts only, the numbers of students who passed all the three subjects. So in our question, the number of students who failed in the accounts only. See, before that, what are the various information given in the question, which we are written separately here. So here our first question is to find out the number of students who failed in accounts only, which we can denote mathematically. That is the number of students who failed in accounts intersection M complement intersection C complement. So that we can find out, see, it is number of students who failed in accounts only, which is equal to number of students in accounts minus number of students in A intersection M minus A intersection C plus then number of students in A intersection M intersection C. If you go for substituting all these values here, then it will become number of elements in A, which is equal to 20, minus number of elements in A intersection M, which is equal to, it is 7, minus numbers of elements in A intersection C, which is equal to 10, plus A intersection M intersection C, which is equal to 4. If you go for solving it, which is equal to 7. So it's showing that the number of students who have failed in accounts only, which is equal to 7. So the first question is answered. Now the second question is that number of students who passed in all the three subjects. But the information which is given here, see, the numbers of students who failed in various subjects. But the question is asked here, it is we want to find out the passing students in all the three subjects. Therefore, first we have to find out the total number of students who failed in all the subjects. That means we have to find out the union of three sets. Then after that, we will go for finding the complement so that we will get the information regarding the number of students who passed in all the three subjects. So here we are going to find out A union M union C, which is equal to, this is the formula for calculating the union of three sets. Numbers of elements in A union M union C, which is equal to, by using the given information, we are going to calculate the union, that is 20 plus 21 plus 27 minus 7 minus 13 minus 10 plus 4. If you go for solving it, it is equal to 42. So this information is actually showing that the number of students who failed in all the three subjects. But the question is that here the number of students who passed in all the subjects. Therefore, the number of students who passed here this 42 is showing that number of students who failed in all the subjects, and we want to find out the number of students who passed in all the three subjects, just go for calculating the complement of the union, which is numbers of elements in the complement of A union M union C, which is equal to numbers of elements in the universal set minus numbers of elements in A union M union C, which is equal to our total universal set is equal to 50 minus number of students who failed in all the three subjects, which is equal to 42, which is 50 minus 42, which is equal to 8. So we can say that the number of students who passed all the three subjects, therefore it is 8 students. Now we have the last question. See, in a group of 30 people, 15 run, 13 swim, 13 cycle, 5 run and swim, 8 cycle and swim, 9 run and cycle, and 5 do all the three activities. Our question is, how many of the 30 people neither run nor cycle? See here, the question is little bit tricky. We want to find out how many do neither running nor cycle. The question is very tricky here. Two groups of people who come under this particular category, that is neither run nor cycle. The first category is those people who do not do anything, which are also come under the category of either run nor cycle. And that means that this group of people who not doing anything, that is also come under the part of neither running nor cycle. I hope you are clear. And see, our task is here, those people who are only doing the swimming is also come under this particular category. So these two group of people we want to find out. First we are going to find out those people who only swim. So from the given question, what are the information given here? Number of elements in the universal set, which is equal to 30 people, and the numbers of people who run, which is equal to 15, swim, which is equal to 13, cycle, which is equal to 13, then run and cycle, which is equal to 5, cycle and swim, which is equal to 8, run and cycle, which is equal to 9, and run, cycle and swim, which is equal to 5. So first question we are going to find here those group of people who are only swim, because they are the part of neither run nor cycle. So it will become, see, numbers of elements in the R complement intersection C complement intersection S. That is numbers of elements in the S minus numbers of elements in C intersection S minus R intersection S plus the intersection of the 3. So by substituting all these elements here, then it is numbers of element in S, which is equal to 13 minus 8 minus 5 plus the intersection, that is equal to 5. So if you go for solving it, then numbers of elements, that is how many people who swim only, which is equal to 5. Thus we can say that 5 people only swim. Now our task is to find out those people who do not do anything. For that purpose, we want to find out the complement of the numbers of people who run, cycle and swim. So here, first we are going to find out the complement. For that, we have to find out, see, what are the union of these three sets, so that we can find the complement as well. So the union of three group, that is run, cycle and swim, which is equal to this given formula can be used for calculating the same. So substituting all the information given here in the given formula, so it will become, see, 15 plus 13 plus 13 minus 5 minus 8 minus 9 plus 5. 5 is the intersection of 3. So if you go for solving it, then it is equal to 24. Now we want to find out the complement of R union C union S. So it will become, see, numbers of elements in R union C union S, the complement. So complement of these three sets, which is the universal set, that is minus, then we have the union of the three sets, which is equal to 24. So it is universal set is equal to 30 minus 24, which is equal to 6. And this 6 is actually showing that the number of people who do not do anything. So our question is that how many of the 30 people neither run nor cycle? Two groups of people are come under this particular category. One is those people who only swim, And the second category, those people who do not do anything. These two group of people will come under this particular category. So here we can find that the numbers of people who do neither running nor cycle is equal to those people who only swim plus those people who do not do anything. So it is 5 plus 6 which is equal to 11. So in this way you can solve this particular example. So let me conclude this lecture here. In this lecture we have discussed the cardinality of a set, which means that the numbers of elements in a given set along with some practical examples. I hope it was very interesting. And you can also find this type of questions, especially in the competitive exams as well. So solve more such an examples to expertise on the cardinality of these sets. So in the following lectures, we will discuss the concept of Cartesian product. I will see you in the next lecture. Thank you.